Okay, the 12.7-12.8c worksheet. I'm going to go over two questions that you guys had on this. Looks like you guys are wanting to see number 1 and number 2. Both of these problems are in radians. Okay, I know that because I see a pi symbol right here. That's the clue that these are in radians. Okay, if you scroll on down and look at like numbers 3 and 4, you can see how that number has a degree symbol there. That's when you'd be doing that in degrees. Okay, so what that changes for you, since this is in radians, is when we get to the step where we're doing the period length and the phase shift, and we're grabbing this part that's in the parentheses, we're placing that between 0 and 2 pi radians, not 360 degrees. Okay, let's answer the 3 quick, easy questions first. Flipped over the midline, that is simply a yes or no question. I can see that I have a negative here. I'm going to go ahead and answer both these parts to both these. See how this one is a negative, but then over here this one is a positive. So on this one, I'm going to say, yeah, this one's going to get flipped, but over here for this one, I'm going to say, no, that one's not. Okay, the vertical shift, that is the same thing as where would the midline be placed. Okay, that's always the extra number that's either added or subtracted all the way off in the end. You can see that there is nothing being added or subtracted to number 1. So that means there is no vertical shift. Our midline will be directly on the x-axis. I'm going to go ahead on number 1 and place that right there. But on number 2, there is a +1 there, so that means our vertical shift is up 1 unit. I'm going to go ahead and place the midline right across here at +1. Okay, amplitude, that's back to the number in front of the trig function, but we always make the amplitude positive. Okay, so if I see that -3 in front for number 1, I'm only going to report that the amplitude is 3, and on number 2, I'm reporting that the amplitude is 2. Okay, hopefully that aspect of it is not too difficult for you. Okay, now we're going to go ahead and come back to number 1, and we're going to focus on how to solve this inequality. I do need you to show some steps on this, despite the fact that you might be, punching some things in on your calculator. Okay, a common mistake that I noticed on the worksheet from yesterday, just on some of you, is you recognized that you needed to say like add pi divided by 3 to all 3 sections, but maybe you added it to the far left, but then you accidentally subtracted it when you got over here to the far right. Okay, make sure that whatever you're doing that same exact thing to all 3 sections. Okay, now when we go to do this, obviously the pi divided by 3's are going to cancel from the middle. Okay, 0 plus pi divided by 3, that leaves me pi divided by 3 on the left. By the way, when you see the little theta symbol, like right here and right here, that's just like the x. And if you're more comfortable, you can make it an x. I kind of put that up here in the directions that the theta symbol is just being treated as an x here. Okay, now here's where our calculator is going to come in. I don't need to see the work for this, but what you're going to type into your calculator is not the pi symbols, but you're going to type into the calculator 2 plus 1/3. Okay, that's just typing in kind of the coefficients, like there's a 1 right there. Okay, so if you type that in, but please, no decimals, no decimals. So 2 plus 1/3, I'm going to switch that back into a fraction, which is 7/3, but then it's on me to keep the pi symbol and reattach it to my answer. Okay, now I don't have the theta symbol by itself just yet. I now need to get rid of the 2/3, and the best way to do that is to multiply by the reciprocal of 2/3. You should multiply all 3 sections by 3/2. That will cancel out the 2/3, leaving you with theta in the middle. If you look to the far left, you can see how the 3's cancel. That leaves me with pi divided by 2. And if you look to the far right, the 3's also cancel there. See how easy that was when I multiplied by the reciprocal? I really didn't even need my calculator at all on that one, because there were some easy things that kind of canceled from the ends there. Okay, now here's where you have to be careful, and I'm going to go ahead and highlight this inequality. This is also tending to trip some people up here. What you want to do is you can pull from this inequality your far left number. That is your phase shift, pi divided by 2. Okay, but what is on the far right is what you should be labeling the far right of your graph. Okay, that represents where your, in this case, sine wave is going to come to a complete stop. However, where the sine wave stops at 7 pi over 2, that is not the same thing as the period length. The period length is trying to figure out how many radians does it span from pi divided by 2 all the way up to 7 pi divided by 2. So what you're going to do is you're going to take where the wave ends, which is 7 pi divided by 2, and subtract from that where the wave begins. Okay, it's always ends minus begins. Okay, I'm okay if you want to use your calculator for this, that's fine. Again, do not enter the pi symbols. Instead, just type in 7/2 minus 1/2. I'm seeing a 3 on my calculator, but again, it's on you. This has to be in radians. You have to attach that pi symbol back in. But you are not using this 3 pi anywhere down here. Okay, it doesn't get used as your labels. Okay, the other very critical piece is that we need 3 more labels on the x-axis. We need to figure out what is the exact middle of pi divided by 2 and 7 pi divided by 2. Well, think about this. If you want the middle of 2 numbers, that means you're averaging those 2 numbers. Okay, now just for this one, I'm going to write down what I'm doing on the calculator, but you don't have to write this part down. Okay, what you're going to do is you're going to type in 1/2 plus 7/2. Okay, so I'm going to add those 2 up. So I'm doing that right now on the calculator. I'm typing that. I'm going to hit enter. And then, because I'm averaging those 2 numbers, I'm going to divide that by 2. If I would see a decimal on my screen, and on this example I don't, you would switch it back into a fraction. I'm just seeing the number 2. But again, it's on me to reattach the pi symbol. The very middle of pi divided by 2 and 7 pi divided by 2 is 2 pi. Okay, then I'm going to repeat that same process to get the 1/4 mark, only this time I need the average of the middle and the beginning. Okay, so what I would type into the calculator here would be 1/2 plus 2. I'd hit enter. Then I'm doing the average, so I would divide that by 2 and switch it back into a fraction. I would see the fraction 5/4, but I have to attach the pi symbol on that. Okay, and then again, to get the 3/4 mark, that is the average of the middle and the end. So you're typing in 2 plus 7/2, hit enter, divide that by 2, switch it back into a fraction, and you should see 11/4. Attach the pi symbol, you got 11 pi over 4. Okay. Now our x-axis is labeled. We already have our midline in place because we said there was no vertical shift, so it's just right here on the x-axis. I do want to look at the amplitude though. The amplitude on this is 3. That means I need to mark off so I can stretch up 3 and so that I can stretch down 3 from my midline, which is at 0. And lastly, I'm going to look at what wave are we graphing? Oh, we're graphing the sine wave. So I know the sine wave should cross the midline, which is the x-axis in this example, at the beginning, middle, and end. So I'm putting those 3 points there. And then I'm looking up here and saying, oh, we said this one should get flipped. So instead of the wave stretching up first and then down second, I'm going to make it stretch down first and then up second. And how much I'm stretching should be 3 units below, that's the amplitude, and 3 units above, okay? And that would give me this as my flipped sine wave, okay? All right, let's go ahead and take a look at number 2 quickly here. Okay, another radian problem. So I'm going to take 3 theta, or 3x plus pi, and put that between 0 and 2 pi radians, okay? I'm going to work on getting that theta symbol all by itself here. Okay, so I'm subtracting pi from all three sections. I see that leaves me with negative pi on the left, 3 theta in the middle, and then pi on the right. Okay, now I don't have the theta symbol by itself just yet, but I'm very close. I'm going to divide the middle by 3, which means I need to do that same thing to all the ends here. Okay, so I'm going to go ahead now and jot this down here. Negative pi over 3 is what I got on the left, and positive pi over 3 is what I got on the right. I'm going to go ahead and highlight that. Okay, now remember, this number on the far left, that is the phase shift. Now be very careful about the period length on this one. The formula is where the wave ends minus where the wave begins. Okay, this is a double negative. It would make no sense to say the period length is 0. Okay, if your wave spans 0 radians, then you don't have a wave because it doesn't exist. Okay, we get a double negative here when we subtract, so if you did a third plus a third, you would have 2/3, and then again attach the pi symbol. Okay, now let's look close at this. The wave starts at negative pi over 3 and it ends at positive pi over 3. Okay, if it starts here and ends there, guess where the middle's going to be? The exact middle would be at 0. So I probably should have centered the y-axis a little bit better here on this, but I'm just going to extend this a little bit. I'm going to mark over here negative pi over 3, and I'll try to mark right here positive pi over 3. Okay, remember our strategy, the exact middle is the average of these two. So on the calculator, you would add together negative 1/3 and positive 1/3, and then you would divide that by 2. Well, that's just going to be 0 divided by 2, which is 0. Okay, so that means the middle is 0 radians. Okay, to get the 1/4 mark right here, I'm going to average negative 1/3 with 0. So I'm going to take negative 1/3 plus a 0, and I'm going to divide that by 2. I'm going to see on my calculator that I get negative 1/6, but then I'm going to reattach the pi symbol onto the answer. And if I do that same thing here, I get positive pi over 6. Okay, let's look back at what wave we're doing. This is the cosine wave. So cosine wave should cross the midline, not the x-axis, the midline. Look where our midline's at on this. We put it up at 1. It should cross at the 1/4 and 3/4 mark. That's at negative pi over 6 and positive pi over 6. We said, nope, we are not flipping this. So that means normally the wave starts up, dips down, and ends up. So we're going to keep with that same pattern here. Only we're going to stretch up the amplitude of 2 units, and we need to go up 2 units from the midline. So that's going to go up to 3. And then we're going to go down 2 units below the midline. That'll stretch down to negative 1. By the way, the middle of this is at 0. And then at the end, at pi over 3, we're going back up 2 units for a cosine wave that looks like that. Okay, hopefully that helped if you were a little confused on some of these. You guys have a great night. We'll talk to you later.